So in the first part of this lesson, we talked about special triangles and exact values, and we talked about how our special triangles are a 30, 60, 90, a 45, 45, 90, and a 60, 30, 90, and we talked about how we came up with these ratios and everything like that. And I kept talking about how it relates to something called a unit circle. So we're going to look at how we develop the unit circle. Some of you may have been really concerned in the first video about how you're going to possibly ever remember all of these ratios. So I'm going to show you a memory trick that's hopefully going to help you remember these ratios. The other thing to know is that we're going to look at all four quadrants of our Cartesian plane and look at how these coordinates actually appear in all four quadrants. But if you just learn quadrant one, you're going to see how quadrant one reflects in the other quadrants, and that will help you a lot. So what we're going to do is we're going to take the information from our special triangles and we're actually going to put them in quadrant one. We're going to look at where our reference angle is 30 degrees, 45 degrees, and 60 degrees. We're also going to look at those special quadrantal angles of 0 degrees and 90 degrees. If we remember, this distance along the x-axis is 1, and we aren't going up or down, so this distance here is 0. So this coordinate's 1 and 0. Now we're going to determine these coordinates for 30, 45, 60, and 90 by looking at our special triangles. Remember, the hypotenuse of our triangle is going to be a unit of 1. So all of these triangles down here have a hypotenuse of 1. So when I actually look at this special triangle here, this 30-degree reference angle triangle, so that means this angle down here is 30, and we're looking at this triangle here. Our x value along the x-axis in that triangle is root 3 over 2. So our x value is root 3 over 2. Our y value, the distance going up and down, is a half. So this y coordinate's a half. We go to our 45-degree triangle. That's this triangle here. Our x and our y are both root 2 over 2. And if we look at our 60-degree triangle, our x coordinate is a half, and our y coordinate is root 3 over 2. If we look at 90 degrees, this coordinate right here, the x value is 0, and this distance is our hypotenuse, so it has a y value of 1. So there we go. We've transformed this information from our special triangles into our unit circle. You're going to notice something here. The x coordinates are all our cosine values because cosine is x over r. And our y coordinates are all of our sine values because sine is y over r. So something you want to write down is that the x coordinate is your value of cos theta, the y coordinate is the value of sine theta, so tan theta then ends up being y divided by x. This is something you're going to have to know. And I told you that if you memorize this first quadrant, you're going to be able to reflect it. So how do you memorize this first quadrant? Well, 0 and 90 aren't too hard. You just look at the coordinate of the point at the edge of our circle. But if we actually look at the coordinates of 30, 45, and 60, if we look at our numerators starting at 60, our numerators are 1, 2, and 3. And then if you go backwards up, your numerators are 1, 2, and 3. Everything that is not a 1 has a radical on it, and all of our denominators are 2. So if we do that again, looking at this, our numerators are 1, 2, 3, and 1, 2, 3. Everything that's not a 1 has a radical on it, and all of our denominators are 2. So you should be able to quickly hammer out what this first quadrant of our unit circle looks like. So what we're going to look at now is I'm just going to switch to a different program. I'm going to switch to Geometer Sketchpad, and we're going to actually look at the first quadrant to start with. So here's the first quadrant that we came up with, the coordinates for 60, 45, and 30. Now I said we can reflect these into our other three quadrants. So that's what we're going to do here. First of all, we're going to reflect this across the y-axis over to quadrant 2, to our 120, 135, and 150. And if you notice, the only thing that changes here is the x values changed from positive to negative. So the coordinates are all the same. If you match the top ones up, the middle ones up, and the bottom one's up, the coordinates are all the same. It's just now that the x coordinates are negative. If you now reflect this down into the third quadrant, well, x and y are negative in the third quadrant. So you just take these coordinates here and you reflect them across the x-axis and you make all the coordinates negative. And then you reflect this across the y-axis again to get this particular set of coordinates where x is positive and y is negative. So if you just memorize this first quadrant here, then you just reflect it across and you're going to come up with everything. The last thing is to add in those quadrantal angles, the 0, the 90, the 180, the 270, and the 360. And there's our unit circle. Now, if you look at your particular notebook, you are going to see that that unit circle that we've just looked at in Geometer Sketchpad is actually in your workbook. They've shown you how all of these things reflect in all of these different quadrants. I will tell you right now, you are going to have to memorize the unit circle. You're going to have to know it. You're like, oh, that's stupid. Well, I don't disagree with you. I'm not sure why they expect you to memorize this. You could normally just look this up in a book somewhere. But when you get to Math 30-1 and you write your diploma exam, they are going to expect you to know this particular unit circle, have it memorized. So we're going to start this year and we're going to continue on with it next year. So it's going to be a good idea to kind of look back at this unit circle, but as I said, you're going to want to memorize this unit circle, and we're going to have a quiz on that tomorrow so that you can see if you memorize this or not. And we're going to use this unit circle to answer some questions today. So it's a good idea to kind of, keep this page handy. You might want to stick your calculator cover on this page so it's easy to flip back and look at this. So, how are we going to use the unit circle to solve some questions? Well, it says find the sine of 240 degrees. So if I go to my unit circle, the first thing I do is I find 240 degrees. And you need to remember that the x-coordinate is cosine and the y-coordinate is sine. So if I look at 240, I know sine is the y-coordinate, so that's negative root 3 over 2. So the sine of 240 is negative root 3 over 2. The cosine of 240, well, if we go back to 240, cosine is the x-coordinate, so it's negative a half. And tangent, remember, is y divided by x. So if we take the y-coordinate, which is our sine value, and we divide it by the x-coordinate, which is our cosine value, we need to remember that when we divide fractions, we keep the first fraction the same, and we invert the second fraction. We flip it upside down and we multiply. So if we look at this, 2 goes into negative 2 negative 1 times. Negative 1 times negative root 3 is positive root 3. And that makes sense. If we look at our unit circle and we look at the cast rule, tangent in quadrant 3 should be positive, and we got a positive result. Next thing I want us to do is use our unit circle to find the exact value of all of these other particular situations. So if we look at the cos of 135, here's 135 on our unit circle. Cosine is the x-coordinate, so it's negative root 2 over 2. If we look at the tangent of 120, well, 120, the y coordinate is root 3 over 2, the x coordinate's negative a half. So we have to take root 3 over 2, divide it by negative a half. And if we work this out, we get root 3 over 2 times negative 2 over 1, and this gives us negative root 3 for tangent. If we look at the sine of 180 degrees, 180 degrees is over here. Sine is the y coordinate, so sine is 0. And if we look at the tangent of 270, 270 is y divided by x. So it's negative 1 divided by 0, so it's undefined. Now, the next example says we have the following points, A and B. They're 2 points on the unit circle. It says if an object rotates counterclockwise from point A to point B, through what angle does it rotate? Well, the first thing I need to do is I need to find negative root 2 over 2 and root 2 over 2. Well, that's right here. It's at 135 degrees. So this first point is at 135 degrees on our unit circle. The second point is negative a half and negative root 3 over 2. So if I go down here, negative a half and negative root 3 over 2 is at 240 degrees. So here's 240 degrees. So how do I figure out the angle it rotates through? Well, if I take 240 minus 135, I get 105 degrees is what that angle rotates through. It says use your calculator to determine to 4 decimal places the coordinates of the point with a rotation of 148 degrees. 148 degrees is not an angle on our unit circle, so that's why we need to use our calculator. So turn on your calculator and hit mode and make sure you're in degree mode. Now, 148 is in degrees, and they want us to know the coordinate, the x and the y. Remember, x is the cosine of our angle, and y is the sine of our angle. So if we take the cosine of 148 and the sine of 148, that should give us our x and our y coordinates in our point. So if we do that on our calculator, if we take the cosine of 148, we get negative 0.8480. And if we take the sine of 148, we get positive 0.5299. So there's the coordinates. You can figure out the coordinates of any point on a circle just by taking the sine and cosine of that value and plugging them in for x and y. The next example says we have a point on our unit circle. It says determine the value of theta. It says where theta is an angle made by the positive x-axis passing through the line T. Now, this is negative 0.88 and positive 0.46. So we know that's somewhere over here in quadrant 2. So how are you going to find what that is? Well, we have to do the reverse. We know that cos theta is negative 0.8829 and sine theta is 0.4695. So how do we find theta? We take inverse cosine of negative 0.8829. And if we do that on our calculator, we go inverse cosine of negative 0.8829, we get almost 152 degrees, and if we round that to the nearest whole degree, it's 152. Let's check that with sine also. Inverse sine of 0.4695. That gives us 28. Well, 28 actually happens to be our reference angle in quadrant 2. So if you take 180 minus 28, it actually gives you 152 degrees. So yes, in both cases, we get the answer 152 degrees. So we now have 2 methods that we can actually solve questions with. So we can either use our chart or we can use our circle to try and get the exact value of these expressions here. I'm going to tend to focus on the unit circle because it's something you're going to have to use more of than the chart. The first question says take the cosine of 300 degrees and add the sine of 330. So the cosine of 300, if we go to 300, cosine's the x coordinate, so that's 1/2. The sine of 330, if we go to 330, sine of 330 is the y coordinate, which is -1/2. So 1/2 minus 1/2 gives us an answer of 0 here. If we look at the next question, it says sine squared of 225. So the first thing we need to look at is we need to look at 225. Sine is the y coordinate, so it's -√2/2. Now, this squared means we're going to square that. Cosine of 225 is the same thing. It's -√2/2, and we need to square that. -√2 squared means -√2 times -√2, which is just +2. 2 squared is 4. We get the same thing here. 2/4 plus 2/4 is 4/4, or 1. The last one asked us to take the tan of 150 divided by 1 minus tan squared of 150. So the first thing we have to figure out is at 150 degrees, what's tangent? Well, it's going to be y divided by x. It's going to be 1/2 divided by -√3/2. So if we take 1/2 divided by -√3/2, we invert and multiply. So we end up getting 1 over -√3, which when we rationalize this, ends up giving us -√3/3. So that's what the tan of 150 is. So this says take 2 and multiply it by -√3/3 and divide that by 1 minus the tan of 150 squared. So that's -√3/3 squared. So if we work this out, if we multiply this out, this is 2 over 1 times -√3/3. Well, 2 times -√3 is -2√3. 1 times 3 is 3. If we look at this, this is 1 minus 3/9. 3/9 is actually the same as 1/3 if we simplify it. So if we just simplify that, divide both of those by 3, we actually end up getting 1/3. So that gives us -2√3/3. 1 minus 1/3 is going to give us 2/3. And now if we invert and we multiply, 3's cancel out, 2 goes into -2, -1 times, I get an answer of -√3. So there you go. You can solve some simple questions using unit circle.